Hello, I'm Bill Rayford. Welcome back to the ibgib channel. My video yesterday, I don't know if I'll still have it up. Apparently I didn't have any sound, which was awesome. If you're watching this and you want sound on that, you're actually interested in the hash-based encryption walkthrough, let me know. Otherwise, I'm not going to waste time on it. So at the very least, you can see me pantomime going through the code. So that said, today, oh, by the way, one of the things I mentioned yesterday that wasn't on the recording, when my air conditioner kicks on, I'm in Texas right now, and we're in the middle of a ridiculous heat wave where, we're well over 100 degrees every day. So when the air conditioner kicks on, this is all I got for the microphone and everything. So but today we're looking at the importing spaces. So right now, the way it works is that ibgib, you have your own data, right? You have your own local first, occasionally connected data. And I do this with Ionic, and I use the concept of spaces. It's kind of like a repository or a repository pattern or just a store, but a space communicates a little bit better information. It's also like a node. It's like the dual of a node. In spaces, the two that we have implemented right now, we have the one outer space, which is the synchronization space, and that uses AWS Dynamo. So when you want to publish something to the cloud, it's not like I have a server going and you publish it to my server. I mean, I could do that here in the future, but then I would have to, take care of your data, know my customer, all that stuff, and deal with your data. But this is about decentralized, distributed programming to where you have more control of your data. And the idea is that you should be able to take, whatever my program is, even if it right now sucks or right now is good or whatever, you start using it, and then later you decide it sucks, you should be able to take your data, move it somewhere else and say, oh, Bill sucks, he's not taking care of his stuff. We're going to send it somewhere else, just like a hard fork on Bitcoin or a hard fork on some of these DLTs. But so to facilitate that, we have the abstraction of just using spaces. So the idea is you have these ibgibs and you have a space, but you got to think of your data from a first person point of view. It's no longer, it just exists and like somewhere in the cloud. So in the cloud, they use a lot of fancy tricks in order to, move things locally all around the world and to get those synchronized. But, we're working at a lower level and being able to work up from that to get to that point. So one of the things that you do, Jesus, I'm blanking on when you take the data, you get the hash of the data, and then you put it in a specific bin. Oh, Jesus. So anyway, not clustering. I mean, you use it in clusters, whatever. If you can read my mind and think what I'm thinking of, that's great. But so the point is that, you have these tricks in order to make one database, what you'd think is one database, but really it's living across, multiple physical systems. So this, the ibgib structure has that in mind from the very beginning with its content addressing, but we do not have that right now to where we can coordinate all of those things all at once. But we do have the abstraction of spaces. So the spaces, it's just like a repo pattern or whatever. It's a bucket to put your ibgib in. And so the two we have right now is an outer space. That's what I was looking at. The first perspective view of the data. So just like us living on, planet Earth, there's the cat. So people, one of the multiple cats we got here, but we call him Mr. B. So B can stand for whatever. From us living on Earth, we have our local space, and then relative to us, there is some outer space, wherever that is. So that's our abstraction for our data. Our data are these ibgibs, which are these timelines. So you got to think of them as like mobile objects or these mobile timelines. So basically, you're dealing with taking timelines and then coordinating those timelines among different spaces. And so if you're a Descartes, the field is already created kind of person, then you can just think of, some coordinate space, but we're talking about bootstrapping our space. It's in a real metaverse in the strictest sense of the word. So we have our local space, which is also kind of like, if you know anything about relativity, you have your local space, and then you have your adjacent, discrete local spaces. So your frame of reference. But anyway, so we have our local space, and we can deal with outer spaces in different ways. And this one that we've implemented, the outer space, is it's a synchronization space. So the idea is that when you interact with it, first of all, when you interact with any space, what you're actually doing, do I want to branch off onto that? We'll turn on screencasting. We'll zoom in a little bit here. Okay, so here's the space. It has some architecture for plumbing, space base here. So if we go to the definition of that, space base extends a witness base, which implements the witness interface, which at the very base of it. So here, ignore the type parameters here. Ignore those. The definition itself is just, it extends an ibgib with data in relation. It's an ibgib. Your basic ibgib with one thing on it, a function, a behavior. So you can think of these it's just a witness is an ibgib that has some behavior that witnesses something. So if you think of a function, but think of a function from a first person point of view, and this function is going to evolve over time, because remember, we're thinking about a granular level of time control of evolving a function. It's very much like, I'm a function, you're a function, a company is a function, a business is a function. But so I'll turn off the notifications here. So from the first person point of view, whenever a function does something, if you think of it a little bit more living than just a function, if you want to think of it as personification or anthropomorphization, that's fine. But you're basically seeing something or witnessing something. It's a little bit higher level than just sensing something. But so anyway, basically it's our one avenue of capturing data. And so what it is that the signature of it is, witness, and then your arg, your incoming thing, is an ibgib, and your outgoing thing is an ibgib. In this case, it's also undefined. So with ibgib, you're capturing the data, the code as data, and so you want the ability to persist, your incoming arguments and your outgoing results. And so that's the one layer above the already thin layer, the semi-structure of the ibgib protocol itself, which if we want a refresher, which I'm sure, one of these days somebody's going to watch one of these videos. If we want to go over here, we'll just look at the ibgib. So the very base interface has just the ib and the gib. And then what I did was, because there are multiple ways you can actually solve the intrinsic and extrinsic stuff, you have the data, which is just a map. It's just like a JavaScript object or a hash map. And then the relations are your named edges. If in graph terminology, they're named edges or named links between nodes. But there's other ways to represent that. Probably too much optimization separating the interface here. But anyway, so the point is, you have the ib, which is metadata that's used in the address per use case. The gib, which is right now just a single hash. It's actually a combination of the punctiliar hash, which is the hash of this record, and then the stream ID hash, which I'm using stream ID because other people might think of it that way. I call it the temporal junction point. The point is it's the beginning of a timeline. It's like a birthday or birthday name. It's like a unique identifier for a timeline. So anyway, you have the ib, the gib, and then data is intrinsic, like internal data, and then the relations, which are pointers, essentially, cryptographic Merkle link pointers to other timelines, or if they're not evolving, other just ibgib single records. Okay, so pull back out. We'll get there eventually. So that's the witness. A witness is any ibgib that has behavior with a single point of access. So we're able to, we'll see with the space, we actually have sort of like a different way of binding calls to our object, but they all get funneled through that witness function. So here you can see all the types: data in, data in, data in. Here's the ibgib in, and then here's the ibgib out stuff, and then here's the witness itself has its own shape. So that's the ridiculous signature size there. Oh, oops. Witness base has some plumbing for any ibgib with behavior. All this stuff is captured inside of its internal data. It's just plumbing for convenience. And then we have a space base, which is plumbing specific to spaces. So it has, a cache service by interface. Route and do command. So this is a command-based witness. So it's kind of like if you're keeping track of your functions of your classes, it uses like a command pattern to where everything gets routed through that witness, but you can actually implement your classes and just implement your routing for like we'll look at this. So here's the routing for what the command is. So if the command has, and all of this is typed easily from the ibgib arg. So in this case, our ibgib are, or the options ibgib, the space options, all this stuff is hard typed or strongly typed. So anyway, so it parses it, if this is a get function, and then you have basically your function parameters. If it's a put function, and then your parameters, like a command modifier, delete. So, but this way we can, depending on our use case for a space, we can persist, what are the individual function calls and what are the individual responses to those. Okay, so space base. We'll pull back out, space base. We're gonna get to the, there we go. So again, two types of spaces we have implemented right now. Spaces are the way that we think of buckets for ibgibs or location execution contexts. This is an outer space, a synchronization space. And the idea is that you could have multiple local spaces talk to this synchronization space. In fact, this is how I use it, to use as like a simple chat or like a group. Like my wife and I use it for shopping lists. Not very well. It's a little bit clunky, which we'll look at that in just a second. But the point is that this is an outer space, and the type of it is for synchronizing multiple local spaces. So since ibgibs work on transforms, which are like event sourcing, they're like events getting applied to an aggregator, or in Git, they're like the diffs getting applied to a branch when you merge. So when you do a commit on a branch, it's Git internally is recording what are the differences in the files, what are the text differences. It has some basic decisions on how to do the merging, how complex a merging is, merge conflicts resolution. That's all that stuff that people are used to. So, but in this case, ibgib has those diffs, but they're not just text diffs. They're self-similar in that they use this same structure. I went into it the last video. But so when you create an ibgib, you know what the hell, we'll just, since I still have the feeling, I guess, to go over basic stuff here. Okay, so these are scripts in the package.json. We have to use HTTPS locally, even just for testing, because we use the crypto library, and the crypto library won't let you run in an HTTP context. So we start up. We're going to create a local space. It's kind of, you can think of a username as a space. It's kind of like in Oracle, a username is a schema, which is very interesting because I was only used to the database world. But anyway, so it's the same kind of thing. You can think of a user as being a space. So I usually just say, blah, 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 but whatever. A little thing here. When I do this command right here, this runs web ext, because this can actually run not only as a web application, it can be a web extension, like a Firefox extension. So anyway, it uses Firefox desktop, and it uses a temporary profile. So it's not going to remember this after this session. That's what I wanted to point out. Okay, so it goes to the welcome screen. I went through the welcome screen last video. My mic is still working. All right. when we go to the home here, so these are tags. Everything in the ibgib uses the same like semi-structure that ibgib data and relations. So here it is. This is our context, this home tag. Its ib is tag home. So the schema for the ib, this is metadata. So like here in the past, here's the past relation. That tag home, I can just tell from this that it's a tag and it's called tag home just from looking at the address. We could add additional stuff, additional metadata depending on our use case. But so, instead of just having the hash be the address, it's the hash plus that metadata. Anyway, so we have the ib, the gib, the internal data, which is right here. This gets copied every time. These are append only, non or monotonically increasing records. And then the relations are named edges, named links. I call them relations. So ancestor, DNA, past, TJP. So right now I wanted to point out the DNA. So this is a fork transform. So like I was saying with Git applies diffs. You can think of those diffs as being transforms. You start with your file, and then you apply a text diff, and then that will get you the next thing. That's like event sourcing. That's how Git works. So it rehydrates your current state. I'm sure it probably has checkpointing or something internally, but so if we duplicate this, I don't have it to where you can just click to it right now. We go up here. We paste in that fork. Here's the fork, and then the caret, then the hash. You can tell that's not a timeline. It's a single hash. So here's our diff, our semantic diff. So in order to get the second one or the first one, it's going to be this past one right here. In order to get this one right here, we first take the ancestor and we apply this transform, this fork transform right here. We called it tag home. We told it to use a UUID, to give it a UUID and a timestamp. We told it to use DNA, which are the transforms. We told it some other things, the encounter, blah, blah, blah. But the point is that we memoized that transform between the two records. And then we gave it, so when you do a fork, you add the previous one in the ancestor relationship. So we forked tag gib. So we added tag gib, which is just a primitive. Anything that has a gib like that is a primitive or doesn't have metadata associated with it. So this kind of forking, this kind of like our base class, our abstract base class that we forked from, and then we gave it or sort of reified it with some of this data. So it created a UUID because that was in our transform, right? So we said use a UUID and use a timestamp. So this thing was created, although really it's this one right here. The first one is in the fork. And it created a timestamp, has an n counter. So this is n equals 1. If we went in the past relation, n would be equal to 0. That's a convenience. And then it added that fork to the DNA relationship, right? And so that's how we create new ibgibs and create ibgib timelines. So you memoize the transform, and then you track it, and then you relate the transforms to where the entire thing is a gigantic cryptographic, Merkle tree or hyper tree or forest or whatever the stuff you want to try to use. So going back to our space, anything that comes in through that witness function, the argument is memoized, and also the output is memoized. And then it has some plumbing to where if you want to persist, let's see if we have, if you want to persist this, you just set that as a parameter. It actually has it in the space base. If you see right here, it's just an abstract function. And so it's just some plumbing. So if your space wants to persist the incoming argument, or outgoing result, you can do that. But there is the trade-off of, now your database, essentially, you're not only creating data for the data you're talking about, you're creating this, metadata also and throwing it into the database. Or depending on how you implement your space, you can have those in separate databases. You can have this, written to a log file or whatever, however you want to persist that. But the plumbing's there for when we create other adapters. But speaking of adapters, that's my point. Now we're going to pull it all back. This is an outer space. It's an adapter that uses, as you can tell from the name, it's a DynamoDB space. It actually also uses S3 for larger files because DynamoDB has a limit on the size of the record. So when you go to put something into the space, first you talk to the space via a simple protocol, and then our implementation of the space interprets that through that route and do command. So in this case, it does the basic route and do command for the plumbing that we have, which is, puts and gets. Basically, a space is a bucket. You can put something in there. You can get it out of it. But it also has, this particular one has a put with a command modifier of a sync. So that's a special kind of put. So you're putting a timeline into the space, and you're synchronizing that timeline. And so, you route the command, you do it internally. This thing, what it does is that it looks at the timelines. It's just like doing a git push from one remote to another remote. So you do the push only in this case where automatically merging things because we don't have the same kind of conflicts that the text does, because we don't live in a loose text file. We live at the semantic level, and we don't worry about order. So it's very much also like a CRDT. If you know about CRDTs, you can keep track of if these transforms are applied, then the CRDT is equivalent to another one. So we end up doing that. But anyway, so the whole adapter, though, is a little kludgy and a little clunky because it doesn't have any real-time feedback. So if I want to see if there's a change, it's not like it's not using WebSockets or anything. You don't get live updates. And so you have to do this long polling. It's unwieldy. But again, it's just me working on this, doing the entire thing. So it was just get something going. Okay, so we'll pull it back a little bit more. So that's our outer space. So again, we're thinking of sovereign data and we have different types of spaces, and the whole thing is about you have timelines, and how do these timelines exist? What are the dynamics between this timeline here and a timeline in a different physical space? So the other space that we have is the local space, right? So here we call it an Ionic space because we're using Ionic. Maybe I should call it a capacitor space, because what this actually uses is the file system right here from Capacitor, right? And so file system and capacitor, if it is Ionic is a technology, it's for hybrid apps, it's for write once, deploy anywhere. So there we go. Why not have, oh, this is on the, it's not the screencast. I don't have Vim Vixen on this one. So anyway, here's Ionic. You write your code in JavaScript or TypeScript, and it deploys for the web, and it can have targets based or was started on the Cordova project for targeting Android and iOS. I think it also does Electron and some others, but so anyway, so file system on Android and iOS actually uses the file system, right? It uses the native file system, but in the web, we're still early days on giving people access to file system type interfaces. You know, you don't want hackers to easily get to your local file system here, so it's coming along real slowly. So this file system, capacitor file system, uses, there's capacitor right there. On the web, it uses IndexedDB. So right here, we look at the developer tools. What this did on initialization was, you know, storage, IndexedDB, file storage, that's a capacitor, name that file storage. So they have an adapter that mimics a file system. You can see here, path is documents, ibgib is my subpath, and then here's the 000 default space. That's what I call a zero space or default space. But so every single one of these is an ibgib record. So it's a little, as you can see, path there. So we just copy one of these things. Oh, that's not what I wanted, the path. I wanted the content. So if we go to ib data, so every single one of these things is this this sort of semi-structure here. Metadata for the address. So this address has a certain schema. There's the hash for this particular ibgib. It has some internal data, and it has pointers to other named edges. So here's the path relationship. So these are named edges. Blah, blah, blah. Okay. But it uses IndexedDB. And so this is our local space. If we were doing a node app or something that had access to a file system, we would use that. But the point is we abstract away from the file system. In fact, you could have a local adapter that uses a graph database, right? Maybe that'd be more appropriate since a file system is essentially a graph database where the links are only one type of edge. You know, it's a containment, it's a hierarchy graph, right? So the point is that before this long rant or sort of discourse here, where are we at? 35 minutes. What I'm supposed to be doing today, or right now, is implementing the ability to import a space. So if we go back over here, when we initialize this thing, if we go up here, this is our local space, testing July 44, and we hit go to here, is to mirror these. So this go to goes to outer spaces. This go to goes to the tags. So these are kind of like, these are special meta ibgibs within our local space. If we go to the go to on the space, it actually doesn't go to the space, it goes to the bootstrap. Obviously that's not very intuitive. And there we go. So this is our bootstrap. This is what our raw bootstrap is. So when the application starts up, how does it know what space to look at? So when your computer boots up, how does it bootstrap itself to point to your C drive or whatever your local hard drive is? I'm not a real expert in that, but eventually you can mount these spaces. So that's essentially what we're doing here, is that we have a local space. The default space ID is like, what space are we using right now? Right? So this is the space ID, not the gib, not anything. This was the unique identifier that we created when we created the space. Here is a list of our space IDs in this bootstrap. So this thing knows only about one space. It knows about this E888, blah, 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 blah. That's the ID. And then here in the relations, these are named edges just by convention. This is just how I coded it. This is the pointer to the most up-to-date version of this local space. So every time you change one of those special indexes, this space, do I have a way of actually going to the space still? No, I don't. Can we do that? Nope. Can we do that? Nope. There we go. There we go. Okay. So if we go to this space, which I used to have a way to get there through the interface, but the Angular router knows if it's ibgib / something, it goes to that something. So here's the space, here's its ibgib. And it is so it's been updated 52 times or 53 or whatever that is, if you include the 0. So when you change these special configuration settings, these are basically like configuration settings. like here is a pointer to the latest index, which keeps a mapping of the temporal junction point, that stream ID, to the latest version, the head, like in Git, you have a pointer that points, it's a non-cryptographic pointer, but you have a pointer that points to the latest, what you think of as the latest version of that branch or the active pointer. We have, it's just the schema. Config key means is the configuration, meta means is meta, special, God knows how I come up with these things. Here's the roots. So these are roots. Within a space, you can have, every single new timeline is added to a root. I'm not positive if I love that still, especially with having spaces, multiple spaces now, but here's the tags. So every time we create a new tag, so let's look at this. This tag is D77, blah, blah, blah. So that D77, that's the punctiliar hash. This 50, here's the stream ID hash. D77, that's the punctiliar hash. That's the hash of this record. That's created by the ib, the data, and the relations deterministically. So D77, if we go create a new tag, testing tag, pick up that. All right. We have our new tag. It's added, but now that's going to be confusing. We're going to update this. Maybe it already did update, I don't know. BCB F4. D77 BCB. So now that's ACA, and that's ACA because that tags got updated. So if we hit the go to, which actually goes to this tags, now it's going to be 1F0. It's going to have the past is going to have a pointer to that D77. So when we created that new tag, it updated this index to our tags to a more recent one. And notice this past only has one link in it. Even though the N is 3, this particular one only keeps 1 in the past. Because ibgib, it allows you to both, like blockchains, have a single pointer to the previous block, which is good for storage. That's lower storage cost, but you're going to have to traverse and load every single node in that graph in order to get to, like, say, the first one. There's no like, oh, what is it 3 steps ago or 10 steps ago? What's the pointer? You've got to traverse and load that entire thing. Maybe they have some special indexing. Who knows how they decide to implement that. But anyway, so we updated this. It updated the local space. The local space has keeps track of those things. Okay. But so we only have one space. So we can actually create a new space with my awesome UI here. You add a space, I'm in San Antonio, Texas, so Central Time, wherever that is for you. So now we have two local spaces. This automatically reloaded. Notice the gib for the bootstrap is not a hash. That's because, you know, we have to have a deterministic way for the app to look, you know, what was my bootstrap? You know, what did I go to? Where do I go when I first start up? So now we have multiple spaces. So like, for instance, we added that testing, right? That testing tag in our testing July 14th. But now if we go to default space, select the new space we just created, will require a restart, right? Submit that, it just reloaded the whole page. Now, default space is BBBBB, default space here, ED, we go down to ED, we see this is our space now, BBBBB. So now, it's not gonna have, if we hit reload here, it's not gonna load anything because it's not in that, it doesn't have that space anymore. But if we go to the go-to tags, now it's going to know, oh, okay. So now we're in BBB's local space. That tag is not here. So if we added a comments, it's going to have a timestamp, but I'm just like throwing it in there. There's the timestamp, 2024 GMT. So now, if we load that other one back up, submit, because this is all local to the browser that affects other tabs. So this tab right here no longer has a valid space. So again, if we do a reload here, not going to be able to load whatever it was in. When we go to tags, it's only going to be those three with the testing, and that comment we just added is not going to be there. So just for the hell of it, let's go back. BBB, submit, will require a restart, reloads the page. This fails. And go to tags, it will have that comment, right? Because those are two distinct local spaces, right? So what happens when I go to start the app and maybe I screwed something up that changes the bootstrap, right? So that's one thing I did. That's this default space ID. I actually tried to change it to 0 space, and then I lost my spaces, and then I can't change it on my phone, which I actually use. So I had to keep that as default space because I have no way of importing a space, even though it's sitting there in the hard drive or in the browser's sense, it's sitting there in IndexedDB. I had no way to link it to the bootstrap. So now, like if we go in here, IndexedDB, very close to the very beginning is going to be the bootstrap. So first, we build up our directory structure, bin, that's for storing pictures and that sort of thing. DNA is a separate place because there's lots of DNA that gets created. ibgibs, that's our main folder. And then meta, that's where we keep updates to those special indexes. It's almost arbitrary, those kinds of divisions. The main thing is it's the space. It's one big bucket. We can divide it however we want. And that is still escaping me the name for sharding. Thank you. Good Lord. Sharding. So when like Cassandra, we just saw something on today. So obviously you're sharding into local spaces, and they have ways of mapping from whatever the thing is, depending on what their algorithm is, says, okay, well, the key starts with ABC, it's in shard 1, you know, it starts with whatever, it's in shard 2. But from the caller's point of view, they only know it's some bucket, right? So for us, we'll have that kind of ability to do sharding with the idea of these spaces. But it's a little bit different because of how we do, you know, the one record that is dealing with timelines in those spaces. Okay, sharding. So, but if we go in here into this bootstrap gib, right? Let's just say we let's just delete this. We'll delete the bootstrap. Okay. Now, when we reload this, it's going to not know anything. It's going to tell us to create another space. Whoops. You know, uh-oh. Whoops. So here's our, here we go. Here's our space that it knows about. Whoops. Right? That's the only one it knows about. But so if we want to import space from storage, maybe storage isn't the right word. File system, probably maybe better. But see here inside, this is just looking through the IndexedDB for this app. So it already has, it's reusing the default space, but we want to be able to not just have whoops, we want to get our testing July 24th back, right? So when we click on that, instead of going into it, or we should be able to say, you know, this is the space. Oh, it's, never mind. When we go into the meta, which is where we store things, here is where that space is. Or we could go, if we go back, yeah, it's an awful UI there, but we go into the zero space and go into meta. This should have all of them. So the zero space has references. I have it to where when you create a space, it is witnessed by both buckets. It's witnessed by the local zero space, and it's witnessed by itself, which is an interesting thing. Because the space, the data for the space, it's just configuration for what that space is. So if we go, to one of these spaces and look at the data, right? So I just yanked that into the clipboard. If we go to this space, its data, this is just the configuration for the space itself. So it tells you what is its, what version the data is. Usually I have that just implied, but I went ahead and add an explicit version. UUID, the name is whoops. And then these are just settings for how it's storing its information and how it behaves. But so I have the space witness itself. And so using these settings, it stores this entire record and any updates to the record in its own space. But it does that in the zero space, excuse me, and within itself. That way you can just project the or copy the file structure if it's on a file system, and then it has a reference to itself, so you can just load it from itself, or so it's double stored there, or the zero space. Okay, so all of that already for an hour now. And yeah, I'm gonna have to go pick up the woman. Okay, a lot of talking for not getting to that yet. So I won't do any more of these kinds of the basics, going over a lot of the basic stuff, or not as much anyway. So I can actually get to some coding while doing these streams. So well, I guess I'm going to change the title here, and we'll see. We'll see if we can get a coding session on this tomorrow. I don't know. We'll see. All right. Thanks for watching, and we'll see you next time.